Hey everyone, welcome back to your math class. Today we're going to be going into lesson 4 where we're going to be doing more work with decimals. Now this lesson was originally going to be called decimals and percentages, but I've decided we're just going to spend today on decimals only, and then we will jump into percentages in our next class. So let's dive right into it. So the plan for today is we're going to start with a brief review of last lesson, namely how to add, subtract, multiply, and divide numbers involving decimals. Then we're going to do a few practice problems, one word problem. So I've said word problems there, but we're only going to do one. And then we're also going to talk a little bit about how to spot repeating decimals when you're doing a decimal long division problem. So this lesson might be a little bit shorter than the ones before it, and maybe the ones after it. I'm slightly under the weather today, so I've decided to take it a little bit easy on myself and a little bit easy on you guys. But rest assured, we're going to get through a few practice problems, a couple for addition, a couple for subtraction, a couple for multiplication, and 3 for division, I think. Just so that we can do that extra one with repeating decimals. And then there's going to be a word problem, and that's it. So let's begin with a brief review of decimal addition and subtraction. So there's a couple key points. The first is that in order to add or subtract decimals, we need to make sure that we line up the decimal point when we're doing our long addition or long subtraction. So you can see these are the same two examples that I pulled for the last lesson. So in each case, I've just lined up the decimal points. And then you just proceed as usual with your addition or your subtraction problem. So if you need to borrow numbers, you can from like one column to the left, that's fine. And if you want to mark in an extra 0 somewhere, like for instance right here, if you want to draw in an extra 0 to keep your numbers straight, to make sure that you've got the same number of decimal digits here as you do here so that you line everything up right, that's totally okay as well. You're more than welcome to do that. There is nothing wrong with it. It's just it's the kind of thing that once you get a little bit more practice working with decimals, once you start to feel kind of comfortable with it, then you won't need to do that anymore. But it's totally fine at this stage to put in those extra digits if it's going to help you keep your numbers straight. And yeah, that was the second point on the screen. I didn't even realize that. But yeah, so adding in zeros at the end of your number. So you can't add zeros into the middle, of course, because then you're changing things around. But adding in zeros at the end, after all the other digits, if you just keep tacking on zeros to the end of that, that's not going to change your number, but after the decimal point, of course. So with that, we're going to dive right into some decimal addition and subtraction practice. So you can pause here, take a couple of minutes, go through these 4 questions, and then I will see you on the next slide. So here we go. Now we'll talk about the answers to the addition and subtraction questions on the previous slide. Now, it is a little bit of a pain to try and write out long addition, long subtraction, and to some extent long multiplication and division as well on the computer. So these are the answers to those questions. I'm hoping I haven't made a mistake somewhere, but I think everything on there should be good. So see if that matches your answers, and if not, then take a moment, talk with each other, talk with your teachers who's present, and if you're still confused, then leave something in the comments so that I can come back to it and we can have a discussion about that as needed. So now moving right into decimal multiplication and division, this is the area that requires a little bit more time and care, because with addition and subtraction, that's basically like your regular old long addition and long subtraction, right? So there's nothing too new there except for lining up the decimal point. That's not particularly confusing most of the time. So that's why I wanted to kind of breeze right through it. But of course, if you guys have questions, please let me know. I can always make another video going through some more examples of long addition and subtraction involving decimals. But it is relatively straightforward because it's almost the same as long addition and subtraction, which are 2 of the most basic concepts that you end up doing in math. So if you have questions, let me know, but if not, we're going to jump right into the next section. So we're going to review on this slide multiplying decimals. So first things first, when you're doing decimal multiplication, you can just ignore the decimal point. So you have a multiplication problem like this one that we looked at last lesson, 2.56 multiplied by 0.2. You can just ignore those decimal points, and in the case of this 0.2, as soon as you ignore that decimal point, you can pretty much ignore the 0 as well, right? So it ends up, you write it out as 2.56 times 0.2, but what you're going to do in your calculation is essentially 256 times 2. And then what we're going to do is, after you go through this multiplication problem, then you're going to go back in and write in the decimal points. Now, one thing to kind of help you along the way when you're doing decimal multiplication is when you write out the problem, like when you write out your problem to do the long division, write in the decimal points, because otherwise it's really easy to forget afterwards. You write down 256 times 2 because you said, oh, step 1, Mr. Pranav said, ignore the decimal point. So you ignore the decimal point, you write 256 times 2, you get an answer of 512, and that's it, I'm done, I got an answer of 512. But you have to go back and add in the decimal point. So when you're writing out the problem, I would recommend that you do write the decimal point, but then when you're actually doing the calculation, ignore the decimal point. So write it in so that it's there as a visual check that when you're done doing the multiplication, you have to go back in and do an extra step, because otherwise it's really, really easy to forget. So you go through this problem. So ignoring the decimal point, we got 2 times 6 is 12. So we put the 2 down here, carry the 1. 2 times 5 is 10 plus the 1 that we just carried, 11. So we put a 1 down here, and then we carry a 1 over there. 2 times 2 is 4 plus the 1 we just carried, that's a 5. So we have 512 down here, so 512. But now we have to go back in and look at where we put our decimal points from the original question. So in this first term, this 2.56, we've got 2 digits after the decimal point. And in the second term, we've got 1 digit after the decimal point. So in total, we've got 3 digits after the decimal points across these 2 terms. So all we need to do is we need to make sure when we get down to our answer that we also have 3 digits after the decimal point down here. So we got an answer of 512, right? Like if you wrote this out just ignoring the decimal point entirely, then that would be like so. That would be 512. But then you think, oh, hang on a minute, I had a decimal point here and I had a decimal point here, which means that I've got 1, 2, 3 digits after the decimal point. So down here, I need to also make sure I've got 3 digits after the decimal point. So that's 1, 2, 3. And so that means we're going to put a decimal point right here. And then you have the option of putting a 0 in front of that. And you get a final answer of 0.512. And that's all there is to it when it comes to decimal multiplication. So now we're going to go into decimal division. So the key points for decimal division, the first one is you can ignore the decimal while you're doing the long division problem. Just like with long multiplication, I recommend that you write the decimal point in as a mental check to go back to it. And actually, because when you're doing long division, you want this decimal point here to be lined up with that decimal point in your quotient, you can actually write that in right at the beginning. So you write down your multiplication problem. So like what I'm saying is you write down something like 9.67. Oh, that's not a great 7, but 670 divided by 5. And now you know that when you're done the problem, you want to line up this decimal point with the decimal point in your quotient. So if you'd like, right at the beginning, you can go and write in a decimal point right up there. That's totally an option. It depends on how you want to do it, but just putting it out there as an idea if you like that better than going back at the end, because there is a chance again that you just forget. So when you're done, if you don't write the decimal point in right at the beginning, you can go back to it at the end and just make sure that it lines up with the decimal point in the dividend. Hopefully you guys remember that terminology from math classes in the past, that this is the dividend, this over here is the divisor, and that up there is the quotient. And then the last key point is that at the end of the dividend, this number down here, this 9.670, if you need to, you can always add in more zeros so that you get a remainder of 0 as your answer. So there's only two real options when you're doing division involving decimals. You can't just get a remainder as an answer. That's not acceptable when you're working with decimals. So you have to either get a remainder of 0 down here, which means you need to keep adding in zeros to your dividend, or you need to get a number down here that you've already seen as a remainder earlier on in the problem, because that's going to be your signal that we're going to run into a repeating decimal situation. So we're going to see an example of that in a little bit, but hopefully that covers everything for the key points for decimal multiplication and division. So now we're going to jump into some practice problems for decimal multiplication and division. So you've got 2 multiplication problems, 2 division problems. Now, one thing I'm going to say before you start is, so the first 2 problems, you shouldn't have any trouble there. The third question, you also shouldn't have any trouble there. It's the fourth question where I just want to point something out. In this 5.1 divided by 0.3, when you're dividing by a decimal number, sometimes it's useful to do a little adjustment to the question so that you get a whole number as your divisor. So as your number after the division sign, you'd like this to be a whole number. It's just easier to hash out the math. So what you can do is you can think of this division problem right here. You can think of it like a fraction where you've got a 5.1 on top. Normally you won't see decimals in fractions, but you can think of it this way, and I'm going to show you why. So you've got 5.1 on top, you've got 0.3 on the bottom as your denominator. And the reason I'm writing it out as a fraction is because here's where it's easy to see that if you do something to the top number, if you multiply or divide it by a certain quantity, then you have to multiply the other one by that exact same quantity, or divide, depending on what you're doing. So for instance, I want to turn this 0.3 down here, I want to turn it into a 3, not 0.3. I want to make it a whole number. So what do? I multiply this by 10, which is going to give me 3 as a denominator. But then if I'm multiplying the denominator by 10, I also have to multiply the numerator by 10, which is going to give you something else. That does not look like a 0, but that's okay. Which is going to give you something else as a numerator. And then you've got the exact same question, but it's not exactly the same type of problem. So I've put it there just to highlight this little adjustment to the equation that can sometimes be helpful when you're working on the problem. You're actually going to find that this ends up not being a decimal long division question. So that's why we're going to do another one after this. But you can pause here and work on these 4 problems, and we'll look at the answers on the next slide. So here are the answers to the decimal multiplication and division questions on the previous slide. Now, hopefully you didn't have any trouble with this. Of course, if you did, there's no shame in that. Just let me know and we will sort it out. But because it's, again, like I said earlier on in the lesson, because it's tricky to go through this type of question on the computer, I'm going to just leave the answers there and let me know if there's something that didn't quite make sense to you or you all got a different answer. And then I can make a separate video that kind of goes over that. So that's it for our decimal addition, subtraction, multiplication, and division practice, except for repeating decimals. So here's where we're going to jump into an example where we need to spot a repeating decimal. And the example that we're going to do is 1 divided by 3. Right? Now, if I write that out the way I wrote out the questions on the previous slide, that's 1 divided by 3, right? And we want to figure out the answer to that. Now, hopefully you remember from the last lesson that 1 divided by 3, this is the exact same thing as 1/3. Right? This is the exact same thing as 1/3. And the answer, which this is the part that we saw last lesson, is 0.3 repeating, right? With that little bar, that means that the 3's go on forever. So you'll notice here that in this question, 1 divided by 3, that doesn't look like a decimal long division question. This is a whole number and this is a whole number. But because the answer is a decimal and a really special kind of decimal where you're going to end up with a repeating digit, I wanted to just take this really simple example. We don't have other decimals floating around, and I want to show you guys how to spot that repeating decimal. So we're going to work through this problem on the screen, just because it's really important that you guys see this process of spotting. That's how I can tell right there, that detail, that's how I know that it's going to be a repeating decimal. So let's go through this. So we start out with asking ourselves the traditional question, how many times does 3 go into 1? And the answer is, it doesn't. Now, normally, if this was a bigger number, if this was like 25, right, then you'd ask how many times does 3 go into the 2? And it doesn't. So then you tack on that 5 and you ask, okay, well, how many times does 3 go into 25? And then you go through that problem. We've got a bit of an issue here because we don't have a second digit. So we've got how many times does 3 go into 1? It doesn't. And then we don't have another digit that we can add to the problem. We can't turn this 1 into a 10 out of thin air because there's nothing after the 1. It's just a 1, right? It's not a 10, it's not a 20, it's not a 30. It's not something that you can tack on another digit to the end of it. So what do? Well, we're going to tack on a 0 anyway, but we don't want to change the problem, right? Right now it's 10 divided by 3. That's not the question I asked. The question I asked was, what's 1 divided by 3? So how do we make sure that we aren't changing the question? Well, if we put a decimal point here, now it's a 1 again, right? I didn't make it a 10. It's still 1. 1.0, that's the same thing as 1. And now it's a decimal division question, right? Now we've got this decimal sitting in here. So what I'm going to do is I'm going to go and I'm going to throw a decimal point up there in my quotient right now. So how many times does 3 go into 1? 0. Cool. So I'm going to put a 0 up there before the decimal point. And then if you want, you can go through that little step of 3 times 0 is 0. So we have a 1. And now we pull down this 0, right, that we have added in out of thin air, but it doesn't change the problem because you can always add zeros after the decimal point, and that's not an issue. So now we've got a 0 right here. For the rest of the question, we just ignore the existence of the decimal point. So now we ask, how many times does 3 go into 10, right? How many times does 3 go into 10? And the answer is 3 times, because 3 times 3 is 9. So we'll put a 3 up here. 3 times 3 is 9, so we subtract by 9. So we subtract 9 from 10, and we're left with a 1. And right now it's a little bit tricky to see because we started the question with a 1 and we added in a 0 and stuff. But I want you guys to remember, I'm going to actually write this 1 in a different color. I'm going to write it in blue. So we got 10 minus 9 is 1, and I'm going to really emphasize that it looks like a 1. There we go. 10 minus 9 is 1, right? Now we have the same problem of 3 going into 1 and it doesn't, so we invent another 0 right here. We're going to pull that 0 down and we're going to put it right here. And we ask, how many times does 3 go into 10? And the answer is 3 times. So we put a 3 right here. 3 times 3 is 9, so we subtract 9. And we're left with a 1. Now here it's probably a little bit easier to see that now we're just repeating steps, right? We started with how many times does 3 go into this one up here? right? I colored that in blue. How many times does 3 go into that one? It doesn't. So we brought that 1 down here. So now we have this guy is a 1, right? And we ask, how many times does 3 go into 10? Right here, we got 3 times, became a 9. Or 3 times, so we subtracted 9, so we got a 1. And then we pulled down another 0, and we ask, how many times does 3 go into 10? Then we got a 3, subtracted 9, we've got a 1. And we're going to end up asking ourselves down here as well, if we put another 0 here, and we pull that down, then we get another 0 here. And we're just going to keep doing, how many times does 3 go into 10? The answer is 3. We're going to subtract 9. And we're going to get a remainder of 1. Every single time we do this, we're going to keep getting 1, 1, 1. So the key is, as soon as you start getting the exact same remainder, that's how you know you're going to run into a repeating decimal, because you're going to end up doing the exact same subtraction problem over and over and over again. And that's something that it's a little tricky the first time, but then as you do a little bit more practice, you start to notice these things. So you'll see that in this super simple example, you end up with just 3's repeating up top. Every time that you invent a 0 and pull it down, you're going to get exactly the same remainder. It's going to be a 1, 1, 1, 1 every single time. Now, it's not always going to be that this remainder is exactly the same as the remainder that's right after it. Now, if you guys remember that 1/7, 1 divided by 7, that's also a repeating decimal, but it's not the same digit that's repeating every single time. So there, the thing that changes is this remainder is going to change every time for the first few, but then as you keep inventing these zeros and you pull them down, eventually, somewhere down the line, you're going to get a remainder that's exactly the same as one of the ones that you got earlier on in the problem. And so you're repeating this huge chunk of subtraction problems that you had an 8 here, and then you did that subtraction problem and you got something else. And then you had a different remainder, and then you had a different remainder and a different remainder. And then at some point, you're going to get a remainder of an 8 again. And now suddenly you're in that loop of, I had a remainder of an 8, I did the subtraction problem, got this digit, this digit, this digit, and then I got a remainder of 8. And then I did the same few steps, and then I got an 8. And you're going to see that it just repeats forever and ever. So your only options really when you're doing decimal long division is you're going to get a remainder of 0, or you're going to get a remainder that eventually you find that it starts to repeat. And that's it. What are you going to do? So I'm never going to give you guys those questions. Obviously, there's more to it. Like, we're not talking about other kinds of decimal numbers, the ones that don't repeat. We're not talking about numbers like pi in this lesson, because I'm never going to ask you to divide by pi or divide something that's going to give you an answer of pi. That's not happening, right? So the only kinds of questions that you'll get when it comes to decimal long division with repeating decimals, it might be a couple of digits that are repeating. It's not going to be 6 or 7, because that takes a really long time for you to even notice that, oh, this is going to be a repeating decimal. You got to go 6, 7 places after the decimal point in your quotient. It ends up being a really long problem. So we're not going to do that. But hopefully this is helping you guys understand how to spot repeating decimals in your decimal long division problem. And the last thing that we're going to do today is we're going to go through a word problem, nothing too complicated. So the problem reads, a construction worker wants to build a square-shaped fort for his son. If each side of the fort is 1.7 meters long, what is the perimeter of the fort? So I'm just going to draw out, so I've got this little diagram of a fort up here. So basically what I'm saying is, actually the diagram I have up there is garden, but I just needed it to be a square. So basically what I'm saying is this is 1.7 meters, right? And I'm asking for the perimeter. So I'm asking for this distance all the way around. If each side is 1.7 meters, what's the perimeter of the fort? Now there's two ways that you can solve this. One is making it a decimal addition problem, and the other is making it a decimal multiplication problem. And I'm going to show you both solutions. Try to solve it both ways. If you're done one way super fast, try to solve it the other way and make sure you get the same answer. But you can pause here, take a few minutes, and then we will have a look. So we'll start with the multiplication problem. So if you've got a square, then if you've got a square with a perimeter of, or with a side length of 1.7, then for a square, because all the sides are the same length, we know that this side is going to be 1.7. We know that this side is going to be 1.7. And we know that the last side is also going to be 1.7. So there's two ways to go about it. One way is you add up 1.7 plus 1.7 plus 1.7 plus 1.7, right? You're just adding up these four numbers, the four side lengths. The other way is, you know, every square has got four sides, and you know that in the case of a square, all the side lengths are going to be equal. So I can do the side length, 1.7, times 4, because it's going to be four of those. So those are the two ways that you can go about solving it. So if we do it with long multiplication, it looks like this. So you've got 4 times 7 is 28. So the 8 goes down here. You carry a 2, which I haven't written in. Maybe I should do that. So 4 times 7 is 28. You write in the 8. You carry the 2. And then 4 times 1 is 4, plus 2 is 6. And then we have to go back and we say, okay, well, when I had just my two terms, the 1.7 and the 4, in the first one, I have 1 digit after the decimal point. In the second one, I have 0 digits after the decimal point. So that's a grand total of 1 digit after the decimal point. So I just need to make sure that I've got 1 digit after the decimal point in my answer. So that's why we write the decimal point in right there between the 6 and the 8. Now the other option is to do it via decimal addition. So that would look more like this. So here you've got a lot of addition going on. It's not just two numbers that you're adding, of course, it's 4, but all that matters is that you line up the decimal point for all 4, and that's pretty easy because they all look identical. And then you go through your addition problem and you just make sure the decimal in your answer is lined up. So we've got 7 plus 7 plus 7 plus 7. So if we do that in steps, 7 plus 7 is 14, plus 7 is 21, plus 7 is 28. So we put the 8 down there, carry the 2, and then we've got 1 plus 1 plus 1 plus 1. That's 4, plus the 2 that we carried, that's a 6, and we just drop the decimal point straight down below the decimals that we'd already written out before it. And then because it's a word problem, it's always good practice to put a concluding statement. So you put something that's a sentence that's your final answer. So you've got your answer of 6.8, but because it's a word problem, you should write out a sentence that answers the question being asked. The perimeter of the fort is 6.8 meters. So that's everything for today. If you guys have any questions, as always, leave me a comment, send me something on Instagram, WhatsApp, whatever it is. Hopefully that covers everything that we need for decimals right now. If there's anything else that comes up in the remainder of the unit, I will of course let you guys know and we'll talk about it. But as it stands, that's everything for decimals. So review your fractions, review your decimals, because we're going to jump into percentages next. And then after that, we're going to wrap up the unit and have a little test. So as always, thanks for watching, and I will see you in the next video. Have a good one.